Tracking changes in a table or implementing CDC, or we call it change data capture, is a complex design topic in data engineering and data ingestion space. In the traditional data world, sometimes it is done via update timestamp, where any changes in the table data record the update timestamp and downstream application compare it to identify the changes. Or a row versioning field, where any higher version of row indicate a change. The third mechanism is log scanner. These approaches are sometimes very complex, cumbersome, and logic heavy. Snowflake has a very simple and elegant solution called stream objects. And this object makes your CDC implementation a child's play. Snowflake's stream object takes a very different approach by adding 3 additional meta columns on the top of source table that helps to track the changes. And by combining the source table and stream object, you can track all DML operation and perform any business logic for your downstream system. I am sure you will have the following questions in mind. How to track different DML operations like insert, update, or delete? Are there type of stream in the Snowflake? Can I create a stream on external table or even on transient table? Can I clone a stream object? Does a stream cost a lot? How does a stream track the changes? So, your Snowflake knowledge is incomplete if you don't know a stream. And if you're a smart data professional, stay with me until the end of this video and practice everything about a stream object and learn many more interesting facts. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake data professional. The last 16 episodes in this series already covered from history to architecture to data loading, multi-cluster warehouse, micro-partition, time travel, cloning, data sharing, and many more important concepts. This episode 17, will primarily focus on stream object, or call it change data capture technique in Snowflake. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. Let's understand what is a stream and how does it work. A stream is a first class object residing within a schema. A stream object is created on the top of source table, could be a permanent table or a transient table or a temporary table or an external table. In this example, we create a stream called myStream on the source table called customer. And this is how the SQL syntax looks like. With this simple SQL, your stream object is functional and every insert, update, and delete on the source customer is tracked in my stream object. This stream object records data manipulation language DML made to the source table, including insert, updates, delete, as well as truncate, and metadata about each change so that the action can be taken using the change data capture. When you create the stream object using this SQL statement, 3 additional columns are added to the base table or a source table without our knowledge. The columns are metadata $action, metadata $is update, metadata $row_ID. So the base table plus metadata tracker fields are known as a stream table. When you query the base table, it shows all the current data set. However, when you query the stream table, it shows only the changes, including the metadata fields. Let's go a bit deeper. At 9 o'clock, the customer table has 10 records, and at 11 hours, a few transactions change the state of the customer table. There are total 5 changes, which includes 2 insert operation, 2 update operation, and 1 delete operation. And now the customer table looks like this. If we execute the select star from the customer table, the query will get the result from the customer table, which we call source table or base table. And if we execute a query on the stream object, it will also get the data from the base table with additional metadata column. However, it will only fetch changes and not the whole customer table dataset. We will see this live. We have different kind of a stream. Let's quickly understand. If you have only update operation in a table and you don't have any delete operation, or you just want to track the insert DML and don't really care about the update or delete DMLs, to support that, Snowflake gives a parameter called append_only. By having this parameter while creating a stream, you can tell Snowflake only capture the append operation and keep the CDC limited to insert. This is called append only streams. We have another type of stream called insert only stream. For external table, this parameter is changed to insert only. If you are creating a stream on external table, the append only parameter is changed to insert only. The SQL syntax looks exactly same. However, you have to use external as a keyword and insert only equals to true as a parameter. This syntax is only applicable for external table and not applicable for standard or any other kind of table. Next, Let's understand, can we create multiple streams on a source table? Any number of streams can be created on a source table. In this example, we create a stream named myStreamDelta on a customer table where it captures all the DML operations: insert, update, or delete. We created another stream called myStreamAppend, which only captures append DML, which means it captures only the insert statements. Both the streams are independent of each other and track the changes as per their DML configuration. Snowflake documentation does not give any hard limit on the stream creation. Can a stream be cloned? Let's understand this concept too. Yes, clone is possible for stream objects. We have a customer table and we created a stream called myStream. Now, if we have to clone this stream, we can use clone keyword and create a new stream called myCloneStream. This stream will start tracking the CTC on customer table from the time of creation. Once the clone is created, you can alter it or change other parameters. Both these stream objects are independent of each other, and the clone object will start referring to the source table for any changes. We understood that the stream does not hold any data and it only holds an offset value. So we will understand what is this offset and how does it work. Let's take our customer data as our source table. We have seen in the earlier slide. We are going to create two stream objects on the source table. By creating this two stream, it will be easy to understand the offset concept. The first stream is called Delta Stream and the second is called Append Stream. Delta Stream tracks all the changes and Append Stream only captures the insert operations. Now let's draw a timeline and see the changes over a period of time and how this two stream captures the CTC. These streams are created at 9 o'clock and we can call it version V0 on the source table. Both the streams are having offset value as a V0. Our stream or a CTC are active on a source table and we are making our first DML operation. We delete two records at 10 o'clock and that transaction is recorded as a V1 transaction. Since no data is consumed from both the stream, the offset value remain V0 for both the streams. When we query Delta Stream, it returns two records. The Delta Stream has a V0 as offset value, and to get the result, it compares the current version of the table, which is V1, minus its own offset, which is V0, and returns two record. On the other hand, Append Stream does not return any result as no append has happened between current state of the table and its offset value V0. Hence, the overall result is 0 record on Append Stream. We move to the next transaction at 12 o'clock and we insert two records to the source table. This transaction is tagged as a V2 on our timeline. When Delta Stream is queried, it returns 4 records. The Delta Stream again compares its current offset V0 versus the current table version V2, and that returns 4 record. On the other hand, Append Stream only return 2 record because there are two insert operation, 2 rows got inserted. It compares its current offset value V0 versus current transaction value V2, and it finds that only 2 insert operation happened. It ignores all other delete and update operation. So this is how the offset value stored by the stream helps to identify the delta data or a CTC data between two transactions and fetches it from the source table itself with the help of these metadata columns. Now let's decode how the offset moves forward. When I consume the delta data using stream via DML operation within a transaction, the offset for delta stream changes from V0 to V2 on a successful execution of insert SQL statement. Now, if I execute a query on a stream, the offset V2 is compared with V2 of the source table and it does not find any delta record and it returns 0 result. And this is how the offset keeps moving forward as and when you consume data from the stream table. This also ensures that the data is consumed only one within a transaction and there is no chance of data duplication if the transaction blocks are designed correctly. So this is how the overall offset concept works when it comes to the stream object. So before we move to the next section, I have an important question to ask. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I think you should be. There is a lot of great opportunities out there if you know Snowflake Cloud Data Warehouse. I have been adding a lot of videos to help the Snowflake community to learn Snowflake besides Snowflake certifications. The feedback I got from my audience way high than my expectations. Folks are getting certified at first attempt and scoring close to 100%. Data engineers, leads, architects, and even data managers are learning from my free content. You don't need to buy any expensive courses. Check my playlist. It includes complete hands-on Snowflake guide, SnowPro certification guide, important mock questions for certification, key SQL function series, Snowflake Python and connector series, and many more videos are on your way. So press the like button if there is anything valuable in this video for you. Now open your Snowflake free trial edition and let's learn all the stream concept together. So first, we will create a customer table as a source table, and any DML operation on this table will be tracked by a stream object. So my customer is created successfully. Now I am inserting 10 records to this customer table. Total 10 record got inserted. Select and see the customer data. I can see I have ID, first name, last name, date of birth, active flag and city. Now let's create a stream object to track the changes in the source customer table. And the syntax is pretty simple. Create or replace stream, the name of the stream which is customer stream, on table customer. My stream customer stream successfully created. Let's execute select SQL on customer stream table. We can see there are 3 additional columns added. So the first is metadata $action, second metadata $is update, and third is metadata $row ID. There is no record as no insert, update or delete operation performed on customer source table. Now let's perform a couple of DML operations and start validating the track changes. So first we will start with inserting 2 records to the customer table, customer ID 11 and customer ID 12. 2 record inserted successfully. Now let's validate how the customer stream looks like. Now we can see there are 2 records, customer ID 11 and customer ID 12, along with metadata information. If I execute select star from a customer table, which is my source table, it will show all the 12 records. And the last 2 records are the record which are part of the DML operation, and the customer stream is tracking the changes. Now I am performing a delete operation where I am deleting the customer ID 9. Let's see how many records are there in the customer table. So I have 11 records in the customer table. Let's query the customer stream. Customer stream has total 3 records. Customer ID 11 and customer ID 12 are insert operation, and customer ID 9 is a delete operation. Here the metadata is update flag is false for all of them because we have not performed any update operation. Now let's try the update operation. I am updating 2 records. The customer ID 3 where the city is updated from the old value to a New Jersey, and for the customer ID 5 I am updating active flag from true to false. Before that, let's see how this record looks like. The customer ID 3 has a city entry Chicago, and customer ID 5 has active flag equals to false. So I will make it true. Now let me execute this update statement. One row updated, another row updated. Let's go and first check whether these things are reflecting correctly or not. My customer ID 3 has a new city value, New Jersey, and customer ID 5 has active flag equals to true. Now let's see how the stream object looks like. So each update is captured by 2 rows. Old row is deleted and new row is inserted. So to summarize, every insert and delete, 1 record per operation is available in the stream object. For update, there are 2 records per update operation. The action, metadata fields capture what is DML operation is performed, insert, delete or update. So you can see here, if it is update, this value comes true. And if it is deleted or inserted, is update comes equals to false. So we have understood how the stream object uses the underlying table, adds 3 additional columns and captures all the changes happens to this table. Now let's see how to extract the stream information within your database and schema. Before that, let's check which database and schema we are in. So this is our database TipsDB and Chapter-17 is our schema. So if I run show stream, it will show all the stream within the database and the schema. So it says that I have only one stream named customer stream. It is created on the TipsDB schema Chapter-17, owner is system admin. And it is created on the table customer. And the type is a delta. And is it stale? No, the stale is false. Mode is default. It will go into stale state after 14 days, and it shows the 14 days starting from the creation of the stream object. This is how you can understand the definition of a stream as well as the state of the stream. Now let's describe our customer stream. If I have to get the stream DDL, I can use the getDDL function by passing the stream as a first parameter and the name of the stream as a second parameter. This is how the stream DDL looks like. So I can run the alter statement on the stream object and add a comment. So it says my statement executed successfully. Now let's describe the stream again. And here I can see my comment got updated. Now the next, if I have to unset comment, I can use alter stream, customer stream, unset comment, and I can see my comment disappeared. I can also use drop stream and drop my stream, and that way I will lose the entire tracking mechanism on the customer table. Now, if I want to create another stream on the top of customer table, let's try that out. So my second stream called customer_stream_02 is created successfully. I will come here. So this shows two streams and this is my second stream. And both these streams are available on the customer table. Let me insert some record. So I inserted two additional records to the customer table. Let's see how both stream looks like. So I would have 9 rows because initially I had 7 rows in this stream. Now I got 9 rows, looks perfectly fine. And I can see my number 13 and number 14 are available here. My stream 2 is only having 2 records because this stream is created recently. So it will start tracking all the changes from the time it has been created. So this is how you can use as many streams as possible and address your different business functions. Next, we are going to understand how the append only stream works. We are going to create a customer table called customer_append_only. The table is created successfully. Now I'm going to insert 10 records. I got total 10 records available in my table. Let's validate it. So the table structure is same. It has total 10 rows starting from customer ID 1 to customer ID 10. Now let's create a stream object to track the changes on the customer append only table. So the syntax is exactly same. Create or replace stream append only stream on table customer append only. And here I am adding a append_only equals to true. For a standard stream, this flag is by default set to false. So my append only stream is created successfully. Now let's query this stream object. When I query, it adds exactly the 3 additional metadata column on the source table. Now I am going to insert 2 records to this table. 2 records got inserted successfully. My append only stream should capture this insert operation. Perfectly fine. So I can see I have 2 rows available. Now I'm going to delete a customer ID equals to 9 from my source table. And let's see if my stream captures this change or not. So this change is not captured because this is append only stream. Now let's update 2 records. Now let's see whether they are being captured or not. Again, they are not captured. So this is how the append only stream works. So append only stream only captures the new arrival record. It does not capture the changes which are done on the existing record. Now, if you would like to show all the stream, when I run the query show all stream, so I have 3 stream, customer stream 2, which we have created in the previous section, and now append only stream. They all are created on schema 17. They are all delta type, stale is false. And here, when you look into the mode for standard stream, it looks default. However, for append only, this flag says append only. So this is how the append only stream works. The next part, we will see, can I create a stream object on transient table? So here I am creating a table called customer_transient, and I am using a keyword called transient to create the table. So my customer_transient table is created. It is exactly the same structure. I am going to insert 10 records. So I can see 10 rows are available starting from customer ID 1 to 10. Now next, I am going to create a stream called transient stream on the customer_transient table, which is a transient table. Let's execute on the transient stream. I can see the same behavior. I have got 3 metadata columns added. Let's list all the streams. I can see my transient stream there and I don't see any difference. It looks exactly same and matches with a stream on a permanent table. Now let's describe it. It also looks exactly same. Now let me perform insert, delete and update operation. So I inserted 2 records and I'm going to delete 1 row. 2 update operations are performed. So I can see 11 rows, 1 record got deleted and 2 record got updated. I can see customer ID 3 has a New Jersey and customer ID 5 has a flag true. Customer ID 9 is not available. Customer ID 11 and customer ID 12 both are available new entries. Now I will go and execute on my transient stream. So I can see this is update operation, insert followed by delete. Customer 5 update operation, customer 9 delete operation, customer 11 and 12 are new insert operation. So whether it is a permanent table, transient table or temporary table, all of them support stream object and there is no difference. Now let's understand, is there any relationship between time travel on the source table with the stream object? So here I am creating a customer table where I am setting the data retention time in days equals to 0 for the source table. So my customer table got created. I am inserting total 10 records into this table. So 10 rows inserted. So I have total 10 rows starting from customer ID 1 to customer ID 10. Now I'm going to create a stream called customer 0 time travel stream on the customer no time travel table. So my stream is created successfully. Let's list down all the stream. So I can see customer 0 TT time travel stream is created. So here I can see my stale date is still exactly the same. When I describe it, it also shows the same. Now let's insert 2 records into the source table. Let's delete customer 9. 2 records updated. Now I can see 11 rows. If I query the stream object, I can see exactly 7 rows. So if your time travel values are set to 0 on the source table, it doesn't impact the stream object. A stream object has its own data retention period, which is 14 days by default. Next, we will see how to consume data from a stream. So for that, we are going to create 2 tables. First table is called customer raw and second table is called customer dim. The customer dim is a downstream table and it will try to track all the changes happening on a customer raw table. So let me demonstrate you. So my customer raw table created successfully. I'm going to insert 10 rows to the customer raw table. I'm going to create another table called customer dim table. Customer dim table is a downstream table which generally gets the data from the customer raw table in this scenario. First time, I'm going to insert all the rows from the customer raw table using this insert statement. Now, both the table look exactly same. Let me validate that. So I have 10 rows in my customer raw table starting from customer ID 1 to customer ID 10. Customer dim also has 10 rows starting from customer 1 to customer 10. Now I'm going to create a stream called customer dim stream on a customer raw table. And let's see how does it look like. So customer dim stream is created on customer raw table. It is a delta type and it is a standard stream. Now I'm going to insert few records into this table, delete 1 record and update 2 records as we have done earlier. 1 record got deleted and 2 record got updated. Now here I should get total 7 records as we have seen earlier. So my dim stream has total 7 rows, perfectly fine. Now I would like to only consume the insert operation from my dim stream and I would like to insert those records into my customer underscore dim table. To identify only the insert, my metadata action is insert and update is false. So if I use this statement, I would be able to get only the insert record. Now to consume, I have a 2 mechanism. I can write a statement like this where I'm saying insert into customer dim and I'm selecting the record from the customer dim stream by having the where clause where action equals to insert and is updated flag equals to false. Alternatively, I can also start a begin transaction and commit transaction and I can write as many as SQLs between this statement. So let me execute the transaction. So my transaction begins and I can run this insert operation. So I can see that 2 record got updated and I will first commit it. Now, my customer dim table should have 12 records and my customer raw table will still have 11 records. So I have 11 record on my customer raw table. Customer dim got 12 records and this 11 and 12 customer IDs are available. Let's see how the stream looks like. Since I have consumed the data from the stream object, its offset got changed and now I do not have any data available on my customer dim stream object. So this is how you consume the data from the stream object. Next, we will see how to create a stream object on an external table. So I have created a stage and a file format. I created a customer table called customer_ext. So my customer table is created. Let me select and I have 4000 rows. Now, when I'm going to create a stream object on the external table, I cannot use the same SQL statement. Let me try that. It says that external table must have insert only set to true. Now I'm giving this flag insert_only equals to true. Now my stream object is created. Let's see how does it look like. So this is the stream which is created on external table customer_ext. And here I can see when the stream is created on external table, it has a mode called insert only. And if I'm doing on a permanent table, it is called append only, and all other streams are shown as a default. So this is how you can create a stream object on external table. As your data start arriving your S3 bucket or Azure ADLS Gen 2, it will start populating the data into a stream object. So we have understood how to create a stream object on a standard table, how to see all the stream, how to alter the stream, how to create a stream with append only option, how to create a stream on a transient table or a permanent table, the relationship between a stream and a time travel, as well as how to consume data from the stream object. And finally, we have seen how to create a stream object on an external table with insert only flag. So we have understood how stream captures and track the changes, but how to automate this entire process and make one end-to-end data pipeline. To enable the data movement from stream object to any other table, the task object comes to help us. Task automate and orchestrate a set of SQL command and help us to build an ETL kind of data pipeline within Snowflake. So if you want to build a solid understanding about task, watch my next episode, Chapter 18. I hope you have been enjoying this Snowflake learning series. Press the like button or leave a comment if you have any queries and questions. Thank you so much for your time and attention, and happy learning.